Hello world! Welcome to my second video on The Farmer Was Replaced. So in our first video, during the time lapse and other points of the video, I upgraded the speed quite a lot. I found that some techniques I wanted to show you weren't so obvious when the speed was so high, so I started a new game here. Same code, roughly the same upgrade levels, but I haven't upgraded speed at all beyond the required first point. So, not the same save game state, but very similar. So, we have unlocked operators, variables, and functions and pumpkins. So, the point of today's video is largely going to be on pumpkins, but I thought that I might throw in a little bit of optimization here before we get started. So this is the code we were using before. We're going to create ourselves a new little module here. Carrots. And now that we have functions unlocked, I'm going to make all this carrot stuff a function. So to do that, you'll do def grow carrots. And as parameters here, I'm going to pass in the number of carrots I need, but also the amount of wood and hay that I'd like to come out of the function with. Just, well, because I can. Indent that here. This setup here, once it finishes growing all the carrots it needs, it's going to just like keep walking around the map and not doing anything. We do want to set up here that we will return if nothing needs to be grown. So our main function here, colon. Instead of running all this, we're just going to say grow carrots 1,000, 1,000, 1,000, and that would be the same thing. Now, just as a little quality of life thing, I'm going to put in some default values here. As the minimum wood that we need to grow carrots. Actually, I'm going to set these to 0. And we'll say min wood equals target wood plus 12. Because I know that a carrot seed could cost up to 12 wood and 12 hay. So I'm going to make sure that I add that onto my targets here. So if I just set these to 1100 so that there's something for it to do, hopefully that's going to work just the same. We already have over 1,100 carrots, so actually that's never going to grow carrots. Let's see what it does there. Well, exactly what we need. So that's been a little bit of improvement. So now as I said, the main focus of today's episode is going to be on pumpkins, but I thought we could do a little bit of optimization. I said before, you don't want to optimize right away, just get in and get something that works. But, one thing that's pretty obvious to me is that moving the drone takes much longer than any other line of code. We want it to move as short a distance as possible. And if we can watch what the drone's doing here, whenever it gets to an end of row, it's moving all the way across the map and then over. Now, when it moves across the map, I know it is faster than moving step by step across the map, but I'm pretty sure it is slower than just moving one square. And definitely if we're moving across the map and then over, that's definitely slower than moving one square. So I thought maybe we could do something to improve that. So I'm going to create myself a little utilities module here. Def move next. And use the same code that like every YouTuber uses for this function, but we're gonna try to improve on this. So what I think would be nice is if we move up, over, down, over, up, over, down. And then it'll have to wrap around the map once per field instead of once per row, and that'll be an improvement. I can definitely imagine some better ways to do this, but we could get a lot of gain just by doing kind of a zigzag pattern. Now that's going to work really nicely when we have a 4x4 field like this, but if it was 5x5, then we go up, down, across, and then we'd be in the wrong spot here. It would like never really harvest the first row again. So it's going to get a little bit tricky to handle all the scenarios. But let's just look at what we might do to make this work. V2. So this is definitely going to be a lot more complicated than this is. We're going to be accessing things like the world size and our position a couple of times, and those are kind of slow functions. So if we're going to be accessing a function like that more than once, then I like to put those in a variable. Position X, get position Y, and then size equals get world size. And so basically here on row 0, I want to go north. And then south, and then north, and then south. Now, based on my my gut instinct on this, it's gonna be cheaper to know when I'm at position 0, and need better handling than checking out if I'm at world size. The way I've done this is probably not true, but let's just see here. So on row 0, we're going to say I'm moving up. So odd rows, we want to be moving down. So let's say if x mod 2, this is going to be an odd row. If I'm here at 0, 0, then, well, no, we can't be at 0, 0 if we're on an odd row. But if we're here, then we want to move over. Otherwise, we want to move south. So if y equals, I like to do it this not equal to 0, move south, else move west. So otherwise, we're on an even row. Now, if we're on the 0 row, we're going to need some special handling. Otherwise, not so much. So if x is not equal to 0, then we're going to be moving north. So if we're at the top of the world, then we want to move over. Now this world size in this case is going to be returning 4, but I'm going to be at row 3. I think it'll work pretty well for me to just subtract it at this point here. And say if y equals size, then move west, otherwise move north. Now, if I am on this first row, then I am going to need a little bit of special handling to wrap around the map, especially if it's an odd-sized map, which we're not right now, but I'm going to go ahead and code for it. So if we're on column 0, if we're at the top, no, if we're not at the top, then I'm going to move north. Otherwise, we'll move west, which will wrap around the map. But if we wrap around the map and it's an odd-sized world, then we're going to need to... so we're going to be up here. We're going to wrap around here, but we want to get to the bottom. So we're going to move north again. So let's see what this does. Move next v2. Let's say we want 1500, 1500, 1500. Run it. Oh, clearly I have messed something up here. Oh, well, this doesn't need to be here. Did that fix it? Oh, nice. So now, nope, that didn't work out quite right. It's not really following the last row. I think if y equals the size, okay, here we go. So we only need to do this north move if it's an odd number of columns. Size mod 2, but the size is actually one less than the size, because what we did here, so we're going to say equals 0. I think that's going to straighten it out. So this isn't the best movement path that could possibly exist, but it's definitely much more efficient than it was before. And again, when I had the speed so high, it was really kind of hard to get a feel for this. So that's why I kind of started over, just to be able to demonstrate that. So as promised, today we wanted to look at pumpkins. So we can go ahead and, heck, why? Oh, I'm going to go ahead and let this run in the background. While we work on our pumpkin script here. So I want to do a grow pumpkins function, which is very much like my carrots, where it will be able to grow pumpkins and all of the stuff that's underneath it. So we'll do def grow pumpkins. We'll say quantity pumpkins, quantity carrots, quantity wood, quantity hay. So we don't have to provide all these parameters, but if we do, then it can kind of incorporate them into its process. So the deal with pumpkins is you need to, for best results, you need to grow a full field of them. Because the amount you get when you harvest them is basically the size of the pumpkin in squares of contiguous grown pumpkins cubed. Or not in squares, but at least in length and width. So the bigger, the better on your pumpkins, by a lot. The problem is when you plant them, sometimes they die before they grow to fruition. So you need to go back and make sure that anything that died you replant so it fills out the pumpkin. So the key thing here with the tools that we have available is that we want to make sure that there are 16 fully grown pumpkins. So I guess that'll come into play here. So I'm going to say quantity carrots. We do not want to interrupt our pumpkin growing to get carrots for each seed that we need, kind of like we did with the carrots. We want to make sure that we have enough seeds to grow an entire field and replace anything that was that died before it grew up. So let's see. Seeds needed. Get world size squared. And then I'm going to multiply that by 1.5. In the game, 20% of the seeds die, but just to have a little bit of buffer, and because, sometimes it's going to be more than 20%, sometimes less, I'm going with a 50% extra seeds, just in case. So, if we need this many seeds, we're gonna need, since pumpkin seeds cost carrots, we need to have at least that many carrots. And just kind of future-proofing here, pumpkin seeds, after you upgrade them, get more and more expensive, and so the maximum that they're going to cost is 12 carrots. So I'm going to say carrots needed is going to be this number of seeds times 12. So let's grow those carrots. So I'm going to say we'll do the carrots needed here plus the quantity of carrots that we passed in. And then we'll go ahead and pass through the wood and hay, if those were provided. Ooh. So I've just realized we are possibly growing carrots we don't need, because we might already have pumpkin seeds left over from the last round. So I'm going to say minus num items pumpkin seed. And if we actually have more than we need, then we don't need to go through this carrot stuff. So if seeds needed is greater than 0, then I'll go ahead and grow the carrots. All right. Now I should buy those seeds. And we have unlocked the multi-trade, so we don't have to buy them one at a time. We can just pass in the number we need. Okay, so here we ought to have enough seeds for one full map pumpkin. One full map pumpkin might not be enough for the number of pumpkins we want to grow. So I'm going to wrap this in a loop here. While num items pumpkin less the number requested, we're going to be doing this loop. So next, I told you in this case we're going to want 16 fully grown pumpkins. So I want to keep track of the number I've identified that are ready to go. So num items equals 0. Number ready. Then we're going to say while number ready is less than get world size times 2. Now I see that I'm again calling this function multiple times, and I'd like to avoid that. Now, while I'm growing pumpkins, I may expand the world, so I don't want to only look at it once, but I don't want to look at it more than I need. So I'm going to say world size equals get world size. Let's just say area. that out. Take that out. And then each loop through will recheck the area in case we upgraded the world size. And yeah, so we're gonna need to go 16 steps to go through and look at everything. So we'll say for I in range area. And here's gonna be where the real logic is. So if there's already a pumpkin there, well, again, I like to work with not equal logic when it makes sense. So let's say if it's not a pumpkin here. Then, well, we want to harvest it if we can. If can harvest, then we're going to harvest. And after that, we might have nothing underneath us, or we might have some grass growing. What I'm going to say here is or get any type is none. It's going to try to harvest, but maybe can't. That'll be fine. So then we want to make sure that the ground is tilled for the pumpkins. So we'll say if get ground type is not equal to soil till. And then we're going to plant a pumpkin. So if we got anywhere into this logic where it's not a pumpkin there, we gotta reset our count here. Ready. Because we need to seed 16 good pumpkins in a row. And that's definitely not the case anywhere in this logic tree here. So otherwise, we do have a pumpkin underneath us. If that pumpkin is harvestable, then that's a good pumpkin we can count. Can harvest ready plus equals 1. So this is the same thing as saying numReady equals numReady plus 1. It's just a little bit easier to write. And I think in this game it would perform faster. And really in Python in general, since it's interpreted, the less variables the better. So otherwise it's not ready to harvest. So we need to reset our count. We're going to have to scan back by here and make sure that that's good to go. So once we have 16 pumpkins ready, then we want to go ahead and harvest. Oh, and then we need to move next. And I'm going to use my new move next V2 here. So now we're gonna grow pumpkins 1,000. So the goal of getting these pumpkins here right now is to unlock lists, because lists are very powerful. They're not the most efficient thing for every scenario that you could use them for, but they're very powerful. That's going to take 1,000 pumpkins and 1,000 carrots. So I'm going to also tell it that we want 1,000 carrots. Cross my fingers here. See what happens. Failed. Grounds.soil. Oh, okay, so my move needs to be inside this loop here. Nice. All right, I'm gonna let that run for a moment. We'll see if we can get our 1,000 pumpkins here pretty soon. Nice. So let's see if we can boost anything here. 1.2 thousand carrots to double our production there. Yeah, totally worth it. And you'll see that this isn't efficient at all, really, because it's having to scan until it sees 16 good wins in a row. It'd be really nice if it could go just back to the squares that needed to be rechecked instead of checking the whole map every time. But to do that, we really need access to lists, which is why we're going for that. 1,000 pumpkins. Unlock them. I'm actually seeing another problem here. I'm telling it that I want 1,000 carrots, but if I ran this when I had enough pumpkins, it would never go back and grow the carrots. So I'm going to go ahead and add a command here at the end just to make sure we exit with everything that was originally requested. And I'll tell you what, now that we've done this movement optimization a little bit, we don't need the speed so low, so I'm going to go ahead and start upgrading that as well. That'll get us there a bit faster. Ooh, we got our 1,000 pumpkins. We're gonna need... So this utilities, min, max, absolute, and random. The min, max, and absolute, we can actually write ourselves. We don't need them. I'm not sure how to write random at this point in the game, or if that's even possible. Don't really need it, but they are nice, and I think it'll save execution time to have them. So we're gonna go ahead and get those. I think I'm gonna use them in the next round of pumpkin optimization next episode. 2,000 carrots. Well, we want to get lists here. This will work out fine. It's growing the carrots plenty fast. Oop, there is another little flaw. So it didn't run into this on this playthrough because I was moving so slowly. But you'll see sometimes it wants to go plant a carrot and there's already something growing there, not ready to harvest. So it is... Where is it here? It's buying a carrot seed, but then failing to plant. And so we're starting to accumulate seeds. And that's a waste of resources. So I'm just going to interrupt here and say if num items carrot seeds is less than 1, then we'll buy a carrot seed. That ought to let us burn off the stockpile we collected there. And not build that up again. I think we got enough carrots to upgrade our pumpkins. So with these speed upgrades, it is spending a lot of time just looking around for something to harvest. That's not really good. Yeah, let's go ahead and expand. I think that will improve the situation. And also make our pumpkins way more profitable. Uh-oh. Something definitely went wrong. So here's the problem. I expanded in the middle of it planting pumpkins, and it doesn't have enough seeds to continue doing its job. So what I'm gonna do is say and num items pumpkin seeds is greater than 0. So it will bail out if it runs out of seeds, and it'll have another chance to grow some. Should prevent that issue. Yeah, let's expand again. Possibly shouldn't be doing that because I really want those lists. Because we're going to be able to make the pumpkins even more efficient in the next episode using those. Got a couple other tricks up my sleeve for that episode, but just want to get up to that point now, so I'll stop expanding. I think the optimal map size for a speed run is probably about 8. So we're getting pretty close to that. The maximum it can get is 10. Alright. Got our lists. That's going to give us super powerful stuff. And yeah, I'll see you guys in the next episode where we optimize the pumpkin planting with that new tool of lists. Have a great day.